7, solving equations in one variable. Alright, so there are like 2 lines of notes, so I'm going to give you those and then we'll get started with some problems. Extraneous solutions sometimes can happen with these kinds of problems, and they are solutions that are not actually solutions of the original equation. So we pretty much just have to check whatever answer we get back into the original to verify that it works. The main reason that sometimes something won't work is because it'll end up with a 0 in the denominator, which obviously is going to cause a problem. Rational equations. F of x over g of x equals 0. That's like the form that they have. Right, solve the equation algebraically, support your answer numerically, and identify any extraneous solutions. So basically we're just going to solve it and then check the solution. So number 2, I've got x plus 2 equals 15 divided by x. And I ultimately want to obviously solve for x. So any ideas on what I might need to do first?
Multiply by x.
Yep, multiply by x so I can get rid of it over here. And when I multiply this side by x, I have to multiply the entire thing, not just like one piece of it. So I end up with x squared plus 2x equals 15.
And then you can bring 15 to the other side.
Yep, I'm going to move 15 over and attempt to factor. So x squared plus 2x minus 15 equals 0. And then what would this factor into? X plus 5, x minus 3. Set each piece equal to 0 and solve. So x plus 5 equals 0, x minus 3 equals 0. So x equals negative 5 or x equals 3. So these are my 2 answers, but I need to check them and verify that they make a true statement and work. So anytime we're checking something, we have to leave the left and right side alone. Don't start moving things around. So I'll have negative 5 plus 2 equals 15 divided by negative 5. So negative 3 equals negative 3. Plug in 3. 3 plus 2 equals 15 over 3. 5 equals 5. So both of those are, in fact, solutions to this problem. Right, number 6, 3 over x minus 1 plus 2 over x equals 8. So when I have something like this, I want to basically multiply the entire equation by my common denominator to get rid of the denominator altogether. And then make it so that I'm just saving a step ultimately. So I'm going to be multiplying the entire function by x times x minus 1 because that will get me my common denominator, or get the common denominator but also get rid of it. So I take this whole thing and multiply by x times x minus 1. And when I do that, I'm going to end up with, when I multiply by over here, the x minus 1's cancel, so I would have 3x plus over here, when I multiply by this, the x's cancel, so I'd have 2 times x minus 1 And then here, I'd have 8x times x minus 1. So then distribute and all of that. I got 3x plus 2x minus 2 equals 8x squared minus 8x. And then I need to get everything on one side, so I'm going to move everything to the right. So 0 equals 8x squared. This is 5x, so subtract that. So minus 13x plus 2. Is that something I can factor?
Negative.
Nope, nothing's gonna work. So what might I need to do?
Could we do the quadratic formula?
Yep, quadratic formula. So, just for a refresher, negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, but b is negative, so it's going to be positive. So 13 plus or minus the square root of 13 squared minus 4 times 8 times 2 all over 2 times 8. I've got 13 plus or minus the square root of 169 minus 64, so 105 over 16. So this is giving you your two separate answers right here. If it's one that's like this, I'm not going to make you check them because when you go back and you plug them in to check, what's going to end up happening is that you're going to obviously be plugging in essentially a decimal number that's rounded, and it's going to make your answer like off by a little bit potentially, or look off, but they would still be classified as solutions because if you used completely unrounded answers, it will work out. So if you want to check them, that's fine, but I'm telling you that they're both going to work, and it's going to end up with really weird math if you choose to check them. So if it's something like this where there's something left under the radical that's like not an easy number to work with, then you don't have to worry about checking those ones. All right, the next one say to also do something graphically, but we're not doing that part either. So number 10, x plus 6 over x equals negative 7. Any ideas?
Multiply by x again?
Yep, I'm going to multiply the entire function by x. So I'm going to end up with x squared plus 6 equals negative 7x. I'm going to move that over. X squared plus 7x plus 6 equals 0. Can I factor that?
Yes.
And what do you get when you do that?
X plus 1.
X plus 6 equals 0. So I would get x equals negative 6 and x equals negative 1. Just wrote those in the backwards order, but that's fine. So to check these ones, negative 6 plus 6 over negative 6 equals negative 7. Negative 6 minus 1 equals negative 7. Negative 7 equals negative 7. Negative 1 plus, I'm just going to say negative 6 equals negative 7. Negative 7 equals negative 7. So both of those work. All right, 14. Make them a little bit harder. 4x over x plus 4 plus 3 over x minus 1 equals 15 over x squared plus 3x minus 4. So anytime I have a problem where the denominator is already something that's like in quadratic like form, where it's like something squared, I want to see if I can factor that first, because a lot of times what ends up happening is when I multiply the entire function, things will end up canceling out nicely. So can I factor x squared plus 3x minus 4?
Yes.
And what will it give me when I do that?
X. Minus 4. No, x plus 4, x minus 1.
X plus 4x minus 1. So now notice that happens to work out nicely to where this is x plus 4 and this is x minus 1. So multiply this entire thing by x plus 4 and x minus 1. It'll get rid of my fractions. So when I multiply by this, the x plus 4's cancel, so I will have 4x times x minus 1. Plus, when the x minus 1's cancel, I'll have 3 times x plus 4. And then on this last part, everything cancels and I'm just left with 15. Multiply, I got 4x squared minus 4x plus 3x plus 12 equals 15. Combine like terms and move stuff over. I get 4x squared minus x minus 3 equals 0. And then I need to use the arch method to factor. So factors of negative 12 that give me negative 1.
Negative 4 times 3.
Well, that'll be plus. 4x squared minus 4x plus 3x. So that takes care of that middle term there. And then minus 3 equals 0. At this point then, I factor by grouping. Can take out a 4x, and I'm left with x minus 1. Take out a 3, left with x minus 1. So I'll end up with 4x plus 3 times x minus 1. So then I'll get x equals negative 3/4 or x equals 1. And then I need to check these. So 4 times negative 3/4 over negative 3/4 plus 4 plus 3 over negative 3/4 minus 1 equals 15 over negative 3/4 squared plus 3 times negative 3 over 4 minus 4.
It is the worst.
So over here I'm going to have negative 3 on top. I'm going to rewrite these to have a common denominator so I don't have to rewrite it a million times. So this would be 16 over 4. This would be 4 over 4. I'll deal with that in a second. So negative 3 over 13 over 4 plus 3 over 1/4 equals 15 over, this will be 9 over 16 9 over 4. And then 16 over 4. Wait. I need this over 16. Nine over 4. I need to get that multiplied by 4. So 16, 36, I think. Yeah. So then I get, I don't know. It's taking too long. Negative 91 over 16. Keep, change, flip. Negative 12 over 13 plus 12 over by itself. Something's not right. I'm just gonna type it in. Something's not right.
Do you have to use the original equation?
Yes. Did I not do that?
No, you did. I was saying if you use like the simplified version.
Oh, the simplified one potentially may not tell me if I'm right or wrong, though. I'm just going to use my calculator and type this in at this point, because I don't know what's happening. Oh, I know where it's wrong. Should have been negative 7 over 4.
Can I break something? This is how it's supposed to look?
Shane.
Did I? What did I do?
No, that's not how it's supposed to look.
I stretched a little. I'm sorry.
I don't think you can sit there anymore. Not near the truth. You got to do it. You might take off. You stretch them. Oh, it looks like it's not broken. How did you do that?
I forgot.
Okay. Anyways, this one works. Just weird math. The other one should be easier. Alright, 4 times 1 over 1 plus 4 plus 3 over 1 plus 1, or 1 minus 1, equals 15 over 1 squared plus 3 times 1 minus 4. What do you notice?
Yeah. Undefined.
What?
Yeah, the denominator for the 3.
Undefined. So this one is extraneous. So the only one that works is this one.
I just said that is
All right, word problem. Actually, we're going to hold on the word problems. We're going to do this tomorrow. I'm going to let y'all work on the problems to make sure that y'all know what we're doing before we do the word problems. They're not like hard word problems, but that way we just make sure everybody's on the same page. 5, 9, 11. 13 and 15. So you need to check them. If you use your calculator to check them, like I ended up doing in this one, that's fine. If they're like a weird number, but make sure you actually show that you did check them